This is WPP number 6 on Unit I, Concept 3 to 5. And problem reads, Gabriel inputs $2,000 that he made from selling monsters into a 24 CD that yields 4% interest. So the first part we'll be doing was with compound interest. So how much money will he have at the end of the term if it is compounded daily, weekly, monthly, quarterly, semi-annually, or annually? So first what we have to do is we're going to use the equation A equals P parentheses 1 plus R over N, and to the exponent would be NT. So P would be represented by 2,000 because that's the current amount of money we have placed in the account. R is represented by interest rate, and that's 4%, but we have to convert it to a decimal, so it'd be 0.04. The time, we have it in months, which is 24 months, but we have to convert months into years, so it'd be 2 years. And N, well, there's several different N's we have to look for, so just list it out for daily, weekly, monthly, quarterly, semi-annually, and annually. And we're gonna have to plug this into our calculator to make it easier to find all these values. So what we'll be plugging in is 2,000 parentheses 1 plus 0.04 over N to the exponent to 2N. So plug in that. This is what should be plugged in to your calculator, and you just hit graph, and it'll just show a line, but you should already know that the graph is gonna go up, but it's just appeared this way so we can find the certain points that we're looking for. And this would be the window that you would put into your calculator so that line comes out and you can get all your values. So back to the graph. What we do to find N, we just hit trace, and this will come out. But if you just hit in 365, it'll appear as x equals 365. You just hit enter, and it gives you the number 2,166.5646. What's important is that we only need to go to the second decimal place because we're dealing with currency, and cents only go to the 100 place. So our answer would therefore be, for daily, it'd be $2,166.56. So then we just keep inputting each value. So for 52, it'd be 2,166.51 because we have to round. So 2,166.51. For 12, 2,166.29. For 4, it'd be 2,165.71. Semi-annually, it would be 2,164.86. And annually, we would get about 2,163.2. Since there's no other value, I'm guessing it's trying to mean that we should just infer that there's going to be a 0, so basically 20.20. So 2,163.20. So that solves the first part, as we found all our N's for the amount of compound interest for N. So back to the problem for part B. For part B, it asks, how much money will you have at the end of the term if it is compounded continuously? So now, instead of using this formula right here, we'll be using a different formula, which would be A equals P E to the RT. So using the same values that we have in the problem, again, P would be 2,000 E to RT. So again, 0.04 times 2 years. For this, we just put it into our calculator. So 2000 E, that's not E, 2000 E to 0.04 times 2, and what we get is 2166.57. So our answer for that problem is 2166.57 for part B. Now for part C, it asks Gabriel wants to invest $2,000 into a 36-month CD. So what interest rate does Gabriel need if he wants to make $2,500 just purely off interest in his account by the end of 4 years to go on a vacation to the Bahamas? So again, we're just going to use our equation. A equals P to the RT, but this time we're going to plug in the values.